right, so let's look at the question of why matrix multiplication is defined the way that it is, because it seems like a sort of maybe oddball or complicated way of defining it. So we're going to be studying in this class linear systems. So a linear system is a system of equations like this, and each of these equations is a linear equation. So we call it a linear system. And the meaning of linear in this case is that these equations here, each one of these, it only has the variables x, y, and z present to the first power, never multiplied against each other, and I'm not applying any functions to any of them. All I'm doing is multiplying them by scalars and adding them together. So in other words, each one is a linear combination of the variables x, y, and z being set equal to some value. So to see the relationship with matrices, let's take the coefficient matrix of this system. So I'm just going to extract the numbers that appear in the way that it's written. So for the coefficients of x, I have 2, 1, and 4. For the coefficients of y, I have -3, 2, and 0, since it doesn't appear in the third equation. And for the coefficients of z, I have 1, -1, and 1. Okay, so now if I consider, let's take the vector v to be the vector of unknowns, x, y, and z. Then if I look at a times v, then this is going to be the product of this matrix with this vector of unknowns, x, y, z. And so when we do that matrix multiplication, what do we get? Well, we have across the top, we've got 2x minus 3y plus z. And then going down the second row, we're going to have x plus 2y minus z. And going down the third row, let's just swap colors real quick. We have 4x plus 0y plus z. Okay, and now this last thing I just drew, it might look like a matrix because it's wide, but it's actually a vector, right? So this is one single number. So that's the first entry. Here's the second entry. Here's the third entry. So this is a column vector of length 3. And if we look back at the original equation, we see, or the system of equations, we see that this is supposed to be equal to the vector 1, 5, 2. So the long and the short of it then is that if I take this vector 1, 5, 2 and I give it some name like b, then that means that we have converted that original system. So let me just make a duplicate of it down here. So this is equivalent to a times v equals b for a, v, and b defined as above.